Welcome to Instrumentsdirect training program on the non-contact meters NCMB and NCME ultrasonic transit time flow meter. Our program today will review the software installation, flow setup, output setup, temperature setup, installation, and review. So, how does an ultrasonic transit time flow meter work? Let's look at this example. We have a man who would like to cross the river in a rowboat. The flow is going from left to right. When he gets in the water to cross the river, he's carried downstream very quickly with the current. We monitor how long it took him to transit across the river. Then he comes back across the river, but it takes him a longer period of time to transit across the river because he's going against the current. So let's review that again. When he goes with the current, he goes across the river very fast. We monitor how long it takes. When he comes back across the river, it takes him a longer period of time. The differential between the time across and the time back is a coefficient we derive to use how fast the river is flowing. So the faster the flow rate, the greater the differential. And so in using this theory, we're going to use this with an ultrasonic transit time flow meter. I have a bird's eye view on the right hand side of the screen looking down on top of a pipe. Although different from the man in the rowboat, we're going to ricochet off the back wall here. So I have this sensor in this side of the pipe and the flow is going from left to right. I send a sound burst across the pipe, bounce off the back wall, come downstream to the second sensor and measure how long it took. Well, at the same time, I send a sound burst from this sensor on the right hand side downstream, across the pipe, ricochet off the back wall, come back down to the first sensor, and because it's going against the current, it takes a longer period of time. The differential between going from left to right and right to left is a coefficient we use to derive and how fast the process liquid's going. Now we have different configurations to do this experiment. The picture in the lower right hand corner is very similar to the man in the rowboat. This is called a dual path or a Z, this is called a single path or a Z configuration where the beam is going right across from one sensor to another. This is traditionally used in applications with larger pipe sizes, traditionally 24 inches and larger, or smaller pipe size applications where you don't have enough straight run of pipe or you have very high wall buildup or very old pipe conditions. Picture in the upper right hand corner is what's called a V configuration or dual path. In this case there, we're ricocheting off the back wall and receiving the sensor downstream. This is traditionally used in smaller pipe applications, say a ½ inch to 24 inches, and is the most commonly used because the transducers are on the same side of the pipe, making the installation much easier. Now another thing an ultrasonic transit time flow meter needs is a so much straight run of pipe. So in this case there we have a 10 to 15 pipe diameters as pictured on the left hand side. This is referred to as a symmetrical flow profile. We'll have a bunch of elliptical shapes of flow here, but basically the flow in the center is the fastest and slowest near the pipe wall. These different elliptical shapes refer to as Reynolds numbers, and they'll change throughout the gyration of low or high flow. But you do know one thing that is common between the different blunt and more pointed shapes is if you drew a center line down here, down in the center, the top half of flow would equal the bottom half of flow. This type of condition normally exists in applications that you have your 10 to 15 diameters of straight run of pipe at flows around 10 feet per second. Higher flow rates, more straight run of pipe. Lower flow rates, less straight run of pipe are required to meet this requirement. Picture on the right is referred to as an asymmetrical flow profile or applications that you don't have enough straight run of pipe. For example, I have this 90-degree elbow, flow coming up this 90-degree elbow. On the inside we have a shorter distance, on the outside we have a longer distance, and we're going to get a tumbling effect after the 90-degree elbow. If we would install our ultrasonic transit time flow meter right here, we will probably get an error message and no data whatsoever. So if we went downstream 10 pipe diameters, puts our sensor, and have another 5 on the other side, we'd be good to go for most installations. So what kind of applications do you use this ultrasonic transit time flow meter on? Well, in any aqueous base application, quite frankly. It works in ultra pure liquids up to about 2% suspended solids. Applications with higher level of solids traditionally are used by what's called an ultrasonic Doppler flow meter. And a Doppler flow meter basically needs chunks of stuff in the process liquid to do a good job, and they don't work on clean liquids. So ultrasonic transit time flow meters would work in ultra pure liquids, jet fuel, chilled water, energy management, chemical process, water and wastewater, but not sludge. Surge, yes. Sludge, no. So that's basically the application spectrum of the ultrasonic transit time flow meter. So most applications, if it is not a slurry, is traditionally a good liquid application for ultrasonic transit time technology. Now the features of this device, of course, is that it is a clamp-on flow meter. You just clamp the sensors on the outside of the pipe, so there's no holes put in the pipe, there's no penetration to the pipe, so the installation requires you not to shut down your process to install the device. Because it's outside the pipe, it has virtually no maintenance. The type of application you can use this technology on are basically a half an inch up to 100 inches. The electronics are designed to display flow rate and total, or if you have an energy module, you can measure temperature and BTU. This small little package is new technology, so it has a lot of punch on the transducer output. So in your larger, your cast iron, your nasty applications, although this is a little smaller box, it's more robust than most of the transit time flow meters on the market. And secondly, you'll find that its price point is lower than most devices you'll find. Basic units like $2,200, $2,300 to monitor flow rate and total, and pipe sizes up to 100 inches. Transit time flow meter is bidirectional and measures positive flow and it measures negative flow. And there's a whole host of outputs. The basic model would have a 4 to 20 milliamp output, a frequency output, and you can get a couple alarm points and read MODBUS. And there's other features as we go through the program today. The basic transmitter displays in a die-cast aluminum enclosure, and it's relatively small. It's about 8 inches across, 6 inches up, and a couple inches deep. So it's a very small package with a very large display that you can toggle between flow rate, total, and program it by this 4-button keypad. Ports on the bottom that come in with your conduit, mounting brackets to put on a wall or on a pipe if you'd like. It has a couple different choices of transducer based upon the pipe size. So the workhorse is the DTTN style. It's designed for about 2 to 36 inches. And basically there's a pair of transducers. You strap them on the pipe, and this is a notch where a hose clamp comes through to strap it on the pipe. And we'll talk about this later. This is the alignment point where you look for differential. For very, very large pipe size, we do have a 0.5 megahertz transducer. So again, this is used for very large pipe applications, and this 36 inch is not a rock hard number here on the 1 megahertz, and the 36 here is not a rock hard on the 1/2 inch. It also plays some role on the pipe situation, whether it's a new or old pipe application. Less than 2 inches, the transducers are pipe size specific. So if you had a 1/2 inch copper, you'd have one pipe size, because basically the dimension is this hole here, right here. 2/2 breaks apart like a donut, and you put together with some wire nuts there to hold this C configuration, 2 C's configurations together. But this diameter here is very specific, much like, say, a magnetic flow meter there. So if you had a 2-inch meter, we'd say, is it copper? Is it an ANSI pipe? It'd be a different pipe part number. Price points are less than the 2-inch or larger. So you can literally go 1/2 inch to 2 inch, and you can get this sensor remote or integral to the electronics. A basic package would include the electronics, a transducer, and a set of cable, and a piece of software. The energy model would have the same thing. In addition to that, we'd have some strap-on RTDs so you can do your BTU management. All right, the setup of this device is basically as a 4-button keypad, and when you power it up, you will get the display screen. So you're monitoring what flow is on. If the meter's powered down, it does not lose the data, and it does not lose your last totalized number. Will retain the programming. In this case, they're powered up, and you're going to read flow. When you get in there, you have the choice of programming the display to read in either flow rate or in total. You could toggle back and forth or whatever one you prefer. So if you just want to play in a water meter function, you could just read your totalization. Or you just want to use it for process control, you can monitor its flow rate or have a toggle back and forth. That is your choice. When you go to set up an application, you go ahead and press the menu function, and then once you get inside the menu function, you select the type of units you'd like to read your entering units you'd like your meter to read into. So in this case here, we're going to read into English. After that, we need to go in and specify the pipe information. Now, we have pipe ID, and you can scroll once you get into the pipe OD, pipe outside diameter. You need to specify the real pipe OD. Every manual is included with an ANSI pipe chart guide, and if you have a 6-inch pipe, you don't punch in 6 inches. You remember the spacing of the transducers we just saw there and the trajectory that needs to be calculated. We need to have real numbers when we program a transit time flow meter. So you need to use your ANSI pipe chart book to put your pipe OD and ID in there. If you don't have that, go ahead and take a tape measure or string and wrap it around the circumference of the pipe. Divided by the only thing I remember from high school was pi, 3.14, and that'll give you the pipe OD. So put in the real pipe OD in your pipe programming. You can toggle that back and forth by using the scrolling functions up and down, right and left, and so on. So after you put in the pipe OD, then you're going to put in the pipe wall thickness. Now, if you have an ANSI pipe, everyone says, does it schedule 40, schedule 80? Based upon doing this a zillion times, almost always you have a schedule 40. There'll be some exceptions to that, but they're relatively rare. And when you have a very small pipe application, the numbers are very insignificantly different. They're in tenths of an inch different there. A very large pipe, then that can make a substantial difference in your flow calculation. So start off with schedule 40 to get your pipe information. After that, you select the pipe material. It's a drop-down menu. Pick copper, PVC, carbon steel, and so on. If you have an exotic application, and there's a long list of different pipe materials there, contact us. There's another function you can type in the sound speed for a unique pipe material that you've just invented or something like that. We can help you with that. So we've done the pipe OD, the wall thickness, the pipe material. Now we need to select the type of fluid. In this case there, most of your applications will be water. And what the next question is what if I have something other than water? Well, again, there's a drop-down menu. You can pick kerosene, you can pick oil, you can pick different chemicals and seawater and all these different things there. They're in a drop-down menu. And if you have a bizarre application or bizarre chemical that's not on there, it's an other function. We can give you some guidance on what to put in there. Or what if you have a mixture of two process liquids? So say you're putting this in an HVAC application and I have water and I have glycol. What do? Well, in the old days, you had to crunch out some specific numbers to do something like that. And so what you used to do in the old days, you would take the sound speed of water, which is roughly 4,900 feet per second, and the sound speed of glycol, which is roughly 5,440 feet per second, and you would have to do the math. So the typical mixture would have been 30% glycol, 70% water, and which was very commonplace. And doing the math between dividing those up, the total will come up to 5,055 feet per second. So remember, sound speed of water, 4,900, sound speed of glycol, 5,440. So you'd have to type under other this function to get your flow meter to work. Not so anymore. With today's technology, plus or minus 10% of the sound speed, you just program the application for water. And the meter will then optimize for your best sound speed. So we're taking the little grittiness out of programming the technology. So for most HVAC applications, you're going to use water. Now you have the opportunity to look at 100% glycol. If you had 72.5% glycol and water, then we might go in the other function and do the calculation. For most time though, you're not going to have a mixture like that, but you do have the flexibility. So we'd go ahead and select water for that particular savings there. So after we put all that information, we basically save all that information, and then at the end, it will provide us with the transducer spacing. That's the differential between the two transducers. And the point of measurement between these two different transducers is this horizontal line. It's right after the notch where the hose clamp goes. So you can see here in this very bad picture, right here after this notch, between this point and this point It's the two reference points where you're looking for the differential of the transducer itself. So you can set this device up with a keypad. You can also set this device up with a piece of diagnostic software, which we provide free, and you can also get the software from our website. The USB software is available for download for free. You can use that, and it gives a little more information. There's where you can download the information from the non-contact meters website or the Instrumentsdirect website, and or we provide it with you to a CD. Tools of communication, we use a USB cable to a PC to say hello to each other, and basically when you hook up the key, with knowing that you're hooked up, lower right hand corner will say the COM port that you are communicating, and on the left hand side we'll have some of the diagnostic information. If there's no diagnostic information, you won't see anything. The purpose of the software is not designed to transmit data. This is a setup piece of software. So when you're done setting up, you unplug. Now, if you had problems, it gives us a little bit of statistics, or real-time statistics, and it also gives us some of the current stats. And that'll be the first thing. If you have a meter installed and it's not working, then we would ask you, what is the signal strength? And you can see quickly from the screen that's blown up here, it would tell us flow rate, totalization, and signal strength. Here we got 59.4, which is higher than what you need. You only need a little bit of signal strength there. One thing you need to take a look at is the delta T. If you're getting a strong signal strength and you have a negative delta T, the flow meter is installed backwards. Yes, the meter is bidirectional, but when we set out the door, we set up as a positive flow. You can reprogram for that if you'd like to and leave the transducers installed the way they are. So that just tells you what's going on. It also tells you the last update, and you can reset the totalizer by pressing this button. It'll give us a little bit of diagnostic history. Should you have a unique application, you can take screenshots and send them to us. If you wish to configure this device, there's a configuration button on the software, and the same things we put on the keypad, the pipe OD, wall thickness, and all those different things are available to punch in on your computer as opposed to the keypad. So here's a larger picture of the same device there. We get to select the units, English or metric, and then we basically go and have the ability to program the transducer, the pipe material, and all these different things, the fluid, and then we hit download, goes back to the meter, and we get our pipe spacing information. There are some other features that you can use in this, such as the advanced levels. For example, you can scale the display, and you can scale the 4 to 20. Some people have a leaky check valve and don't want to see the dribble effect. You can put a low flow cutoff in there. There's some sensitivity adjustments if you have an extremely noisy application. So there's some fine-tuned controls that you can adjust, but most of the time never need to touch. So this is for the advanced level, basically, of operation for a unique application. You can set up the output and display tabs. You can also set up the options for rate and total, as well as positive and negative or net readings. Should you have a small pipe transducer, 1/2 inch to 2 inch, life is even simpler. It's more of a plug and play. We will go to the setup and we'll actually drop down the 1/2 inch ANSI transducer, ANSI pipe, and it will fill out all the data other than the processed liquid. Because of course the pipe size, OD, wall thickness, and all those things are predetermined by the transducer. So we're basically going to drop down that information. You don't need any spacing because it's predetermined. So the small pipe sensor is even easier to set up just by dropping down that transducer. You can set up the 4 to 20 milliamp tab. Go to channel 1, and to span your 4 to 20 milliamp, you simply set the base scale rate and the full scale rate for your application. Should you like to test the output of your 4 to 20 milliamp, it does have a calibration test function, so you can basically chip off this button there, and while the meter is not reading flow, you can transmit an output. So you say you wanted something to happen at the half span, and you set the output to half range there. You can basically transmit this to a data logger or recorder to scale your peripheral devices before you actually get the device monitoring flow to make sure your whole control loop is all installed properly. The transducer itself, as I said before, you get them as a pair. It has a notch in the side to install the hose clamp which comes with the kit, and this is the reference point that you have measuring between the two different transducers. You can mount the transducers in the V or the Z configuration. Most of the time people install them in the V configuration because it's much easier to see and to align them. Should you have the opportunity, vertical or horizontal doesn't make any difference, but if you're on a horizontal pipe, I suggest 9 or 3 o'clock, just because you can get aeration on the top of the pipe. You can get suspended solids on the bottom of the pipe, so it's kind of a happy medium installation point. The grease on the face of the transducer. All the time we get the questions, how much grease do we put on the face of the sensor? Usually a tube of toothpaste, toothpaste on a toothbrush kinda is usually sufficient. Depends a little bit about your application. If you have a very wet pipe application, we do provide a silicone grease application. And you do need to take care that you put enough grease on the transducer, wipe off the pipe, and then re-insulate the pipe so you don't have a rainforest inside the pipe that washes away the transducer grease. So in that case there, as long as you seal up the installation of the pipe doesn't sweat, and then you're good to go. The silicone grease pretty much stays there. So toothpaste on a toothbrush for the most part as far as your grease on the pipe. And why use grease? Well, transducer is flat, the pipe is round. We need some kind of a pathway or couplant to go through the pipe. Remember the man in the rowboat? Well, now he's standing in a river, and his brother's off in the distance on a motorboat, and he hears him off in the distance. Well, he goes and takes a dunk under the water, and all of a sudden it sounds like the motorboat's right on top of him. And the reason for that is sound travels faster through the liquid than it does through the air. So in this case, sound travels faster through the grease than it does through the air. So that's why you need an acoustic couplant. Depending upon your application, you have different greases there. So the standard silicone grease covers you under most temperature conditions. If you had a high temperature application, we have some different greases there that basically can keep their consistencies at a higher temperature there. Water-soluble greases are an option. We have them. We don't normally use them for dedicated installation, but if you need them, they're available. But they do tend to wash out. Remember, they're water-soluble, so if you get a moisture, they'll drip out. So they're not designed for long-term installations. So we determine the transducer site. We needed our 10 to 15 pipe diameters. We needed to apply our sonic grease. If we have insulation, we remove that off the pipe. Take a whole piece of insulation off. Don't cut little pockets and little windows and puzzle pieces to put this in because it never works out. Cut the insulation off, put your transducer in the pipe, re-insulate back on top of the pipe. Pipe preparation, no, don't bring that grinder out. We basically knock off anything that's loose. So a wire brush is more than necessary in a rusty pipe there. A rag for other applications that aren't rusty pipe. The good old days, some people used to bring grinders out there to take the paint off the pipe. Not required. So we have our transducers installed. We have our flow meters installed. If you'd like, you can take and use our energy meter option and add a strap-on RTD. An RTD strapped on the outside of a metal pipe. Between the two transducers, we can give you better than a 1% differential. To strap on a platinum RTD, which we provide, you basically get a strap and you get some thermal compound, which is real thick gooey stuff there, that basically is a couplant between the sensor and the pipe wall, and we would basically strap that on the outside of the pipe, and the sensor itself would go back to the electronics. The way we have this programmed basically is it's designed as a plug and play system. No calibration is required. For those who have the need to use their own temperature sensors, 3-wire platinum RTDs, or a wetted sensor that they're providing, you can still use this transmitter as long as you have the energy option, and you can program it yourself for your particular sensors. When you buy it directly from us with our temperature sensors, it is plug and play. No calibration or adjustments required. But we're showing you it does have the flexibility to program it. We do that here. You can set the calibrations up. Basically, you got a temperature for your low temperature reference, and then you'd have to span it for your high temperature references there. So we program it for freezing at the 212 degrees for most applications with our temperature sensor. So in using the temperature programming, you have the ability to monitor your individual temperature. We need to program it for set a low point and a high point. We need to install the temperature sensors on the pipe, and the sensors go back to the electronics. And the next step is communications. So the picture you see before you now is a picture of a transmitter, and this is an energy module, because it has flow rate on the supply, it has temperature on the supply, and it has temperature on the return. So this device will then be able to read flow rate or BTU. So what do I do with that information? Well, I have the ability to transmit it. Of course, a local display, but I have the ability to transmit with a 4 to 20 milliamp output. I have the ability to use MODBUS. I have the ability to use Ethernet. Wow, everybody keeps asking for Ethernet. Why good is Ethernet? Well, this has its own IP address. So you know that new printer you just bought, went down the hallway and plugged it in, then you come back down the hallway and you can say hello to the printer on your computer. Well, you can do the same thing with this flow meter with the Ethernet communication option. Need to get a little fancier for your HVAC or building diagnostic system. Again, it works with MODBUS, TCP/IP, BACnet IP, BACnet MSTP, BACnet vanilla, chocolate, and strawberry. BACnet, every time we talk, is a different flavor of BACnet. So we have the methodology to give you the whole host of different communication options with this type of technology. If you were to plug it in with your Ethernet information, here's some of the information you could pull directly from the meter. Again, it's got its own IP address. Go down the hallway, read your data for continuous monitoring. Here's the MODBUS register for MODBUS outputs. And here's the beginning mapping for some of the BACnet different outputs. So the list goes on and on and on. The technology is a clamp-on non-invasive device, so no maintenance is required as long as the equipment is operating. If the flow meter stops reading, go take a look at the transducers and see if somebody knocked them off the pipe. Other than that, there's no moving parts. So some facilities do require a periodic or an annual inspection. Fine. You can always remove the equipment, which is really not practical. You can rent a portable ultrasonic transit time flow meter from us, or have us come to the site to do an annual inspection, so it's a side-by-side reference there. Or you can hire local services or rent the device and monitor it yourself. So if you do need to field calibrate it, really not that much of an issue. It's more field verification, and that's the case there. We can provide you with the equipment, either rental, purchase, or you can use local services to do the same thing to answer that particular question. Instrumentsdirect, well, we are an ultrasonic flow meter company, and of course we rent flow meter and we sell flow meters, do some special flow surveys, and when it comes to product development and manufacturing, we have a division called non-contact meters, which is the manufacturer of ultrasonic transit time flow meters. Engineering and calibration laboratory manufactures custom transducers for different people and manufactures some temperature kits and signal kits for many of the portable ultrasonic flow meters that we provide. So for more information about all these little goodies we talked about, you want to download the software we just talked about. You need to get some cables or grease or other things like that. Go to instrumentsdirect.com to get that information. And if you want to learn some more about this product or other products, there's a button across the website on the top that says Learn. And we have a whole host of training videos and other webinars there for your viewing. So we'd like to thank you for attending our program today. If you have additional questions about setup or training of the NCMB or the NCME or need a quotation, please don't hesitate to give us a phone call today at 888-722-5543 or drop us an email. Thank you for attending our program today.